Hello YouTube and welcome back to another video. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is actually a challenge lab within Boson. And it's called Boson CCNA Challenge Lab number 2. So let's read the objective for this challenge lab right here. It says, in this lab, you will configure a network in which packets are routed between two separate VLANs. When your work is complete, you should be able to ping every device on each LAN from host 1 by using IP version 4 addresses. This lab requires you to know how to configure IP addresses, configure CDP, Link Layer Discovery Protocol, LLDP, and configure access ports and trunk ports, understand Rapid Per VLAN Spanning Tree Protocol, PVST+, configure VTP, or VLAN Trunking Protocol, configure Ether channel with Link Aggregation Control Protocol, or LACP, and configure inter-VLAN routing. Ideally, you should complete this lab only after you have completed other labs that cover this material. All right, so we're going to be doing a little bit of everything in this lab. So it's going to be a pretty good lab, I think, in my opinion. We can look at our topology right here. We can see we have a connection up to router 1 from switch 1. Between switch 1 and switch 2, it looks like we have 4 redundant connections, and we have this bundled into a one logical interface, or a ether channel, or port channel if we want to call it that, for redundancy and also better throughput on the network. So that is a good feature to have. And then we have connections out to host 1 and host 2, which are most likely going to be on separate VLANs within this lab, so we can configure inter-VLAN routing. All right, so let's take a look at the commands that we're going to be using for this lab. We have channel group number, mode auto, desirable, on, active, or passive. This assigns an interface to an ether channel group. We have configure terminal, which enters global configuration mode from privilege exec mode. We have copy running config to startup config. This saves the configuration file. We have enable, which enters privilege exec mode. We have encapsulation.1q VLAN ID. This configures a router interface to be an 802.1q encapsulation for the specified VLAN ID. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have interface type number, sub interface ID. This creates a sub interface. We have interface range, start port and ending port. This configures a range of interfaces. We have IP address subnet mask. This assigns an IP address and subnet mask to an interface. We have IP config / default gateway IP address. This is used in NetSim to assign a gateway IP address to a workstation interface. We have IP config / IP address subnet mask. This is used in NetSim to assign an IP address and subnet mask to a workstation interface. We have LLDP run, which enables LLDP globally. We have no LLDP run, which disables LLDP globally. We have VLAN, we have name, VLAN name. This configures a name for a VLAN. We have ping IP address. This sends an ICMP echo request to the specified address. We have show CDP neighbors. This displays information about directly connected Cisco neighbors. We have show ether channel, channel group number detail, load balance, port channel, summary, or protocol. This displays ether channel information. We have show interfaces type number. This displays interface statistics. We have show interface type number trunk. This displays interface trunk information. We have show LLDP neighbors. This displays information about directly connected network devices. We have show running config, which displays the active configuration file. We have show spanning tree, which displays spanning tree configuration. We have show VLAN, which displays parameters for all VLANs, contains the VLAN name, status, ports that are assigned to it. We have show VTP status, which displays the current VTP status. We have shutdown, which disables an interface, and we have no shutdown, which enables an interface. We have spanning tree port fast, which enables port fast on an interface. We have spanning tree VLAN ID port primary, which configures the spanning tree priority value to ensure the switch becomes the root bridge. We have switch port access VLAN ID. This assigns an access port to a VLAN. We have switch port mode access. This configures an interface as an access port. We have switch port mode trunk, dynamic auto, or dynamic desirable. This configures the DTP mode for an interface. We have switch port no negotiate. This disables DTP on an interface. We have switch port trunk encapsulation .1Q. This configures an interface to use 802.1Q encapsulation. We have VLAN number, name, VLAN name. This curates or configures a VLAN with an optional name. We have DTP domain, domain name, which assigns the VTP domain name. We have VTP mode, server, transparent, and client. This configures the VTP mode. All right, so that is all of the commands. Let's take a look at the IP address table. We can see that we have our router, which is going to have two sub interfaces within the Fast Ethernet 00 physical interface. We have .100 for VLAN 100 and .200 for VLAN 200. We can see the different IP addresses that each sub interface is going to be using. And we can see our subnet mask, which is a .240 of subnet mask, okay? So our switches, both of our switches are going to have interfaces in VLAN 100 and 200. You can see that IP address information. These are going to be the SVIs on each switch, and that also gives us an IP address to remotely connect to this device if need be. All right, so let's go ahead and move on. We can see our host addresses as well. So everything looks good. So let's go ahead and get into our lab task for this lab. I'm going to keep the topology up here in the top left. We're going to be doing our reading in the top right for our lab, and we're going to be doing our configuration down at the bottom. So task 1, it says, configure the basic layer 2 network. It says, in this task, you will manually configure ports on switch 1 and switch 2 as access ports and trunk ports. You will also configure VTP VLANs, Rapid PVST Plus, and Port Fast feature in order to prepare the network for layer 3 configuration. So we're going to be doing all of our layer 2 information now. So it says on switch 1 and switch 2, issue the command to disable any port that is not directly connected to other devices. So if we go to switch 1, all right, go to switch 1, and let's do an enable, and let's do a any port that is directly connected to other devices. Let's do a show CDP first. So CDP neighbor. All right. So we see that the Fast Ethernet 1, 2, 3, and 4 ports are all connected to another device. Let's do a show IP interface brief. All right. And it says disable any ports that are not directly connected to other devices. All right. So let's go ahead and do a configure terminal. Now we want to look at the interface numbers. So if we take a look at the interface numbers, we can see that the Fast Ethernet 05 through 010 are not connected to any other interfaces because their status and protocol statuses are in the down state. And also these gigabit Ethernet connections as well needs to be in this range. So let's do an interface range. Let's do Fast Ethernet 05 through 10, comma, gigabit Ethernet 01, comma, gigabit Ethernet 00, and hit enter there. And let's do a no CDP. Let's do a no shutdown. Let's do a shutdown. Sorry, shutdown. Administratively shut those down. All right, and let's do the same thing over here on switch 2. It says disable any ports that are not directly connected to any other devices. So let's do the same thing over here. Let's do an enable. Let's do a show CDP neighbor. All right, and we do a show IP interface brief. We can see that the fast Ethernet 00 and the same thing 05 through 010 over here, and both of the gigabit connections as well. So let's do a configure terminal. Let's do an interface range fast Ethernet 05 through 10, comma, fast Ethernet 00, comma, gigabit Ethernet 00, comma, and gigabit Ethernet 01. All right, hit enter there, and let's do a shutdown on these. All right, so all of those are now shut down. So number 2, it says on switch 1 and switch 2, issue the command to manually configure the range of ports that connect the switches as IEEE 802.1q ports. Ensure that all 4 ports on each switch are identically configured. In addition, issue the command to disable DTP. All right, so on switch 1, it wants us to manually configure the range of ports that connects the switches together. So if we do a do show CDP neighbor again, we can see that the fast Ethernet 1 through 4 interfaces connect to switch 2. So let's do an exit, and let's do an interface range fast Ethernet 01 through 4. All right, now what does it want us to do? It wants us to configure it as a trunk. Let's do a switch port trunk. It wants us to do encapsulation .1q. Let's do a switch port mode trunk, and then let's do a switch port no negotiate. All right, now let's do the same thing on switch 2. Let's do a do show CDP neighbor. We can see that the fast Ethernet 01 through 04 ports on this switch connect to switch 1. So let's do an exit. Let's do an interface range fast Ethernet 01 through 4. Interface range fast Ethernet 01 through 4. Let's do a switch port trunk encapsulation .1q. Let's do a switch port mode trunk. Let's do a switch port no negotiate. All right, so that was all of the commands. It said 802.1q trunk, ensure that all 4 ports are identically configured, and issue the command to disable DTP. All right, good. On switch 1, issue the command to manually configure the port that connects to router 1 as an 802.1q trunk port and disable DTP. All right, so on switch 1, it said issue the command to configure the port that connects to router 1. So if we do a show, let's do a do show interfaces. Do show interfaces. Okay. Let's do this. Let's do a do show run. See if we got these interfaces labeled, and we do. So the description for the fast Ethernet 00 is a description up to router 1. All right, so I wanted to make sure that was the connection up. So let's do an exit. Let's go into the interface for fast Ethernet 00, and let's do a switch port trunk encapsulation .1q. Let's do a switch port mode trunk. Let's do a switch port no negotiate. All right, so number 4, it says on switch 1 and switch 2, issue the commands to configure VTP with a domain name of example court. Allow the rest of switch 1's VTP configuration to remain configured with the default settings. Next, configure switch 2 as a DTP client. All right, so on switch 1, we're already here now. It says issue the commands to configure the VTP domain. So let's do an exit. Let's do VTP domain. And we want the name to be example court. All right. Hit enter there. Do the same thing on switch 2. Let's do an exit. Let's do a VTP domain of example court. Hit enter there. All right. And it said make the like everything else to be the same and make switch to a VTP client. So let's do VTP mode client over here on switch 2. All right. Number 5 says on switch 1, issue the commands to configure VLAN 100 and name the VLAN cells. Next, verify that the VLAN is also configured on switch 2. So let's go to switch 1. Let's do a VLAN of 100, and we're going to give it a name of cells. All right, let's do an exit, and let's go to switch 2. Let's do a do show VLAN brief. And as we can see, the VLAN 100 VLAN was created on switch 2 because we are in the same BTP domain. So any VLAN that's created on switch 1 will be propagated over to switch 2. And we can see that that VLAN was the VLAN 100 and the name cells was propagated over to switch 2. All right. So on number 6, it says on switch 1, issue the command to configure VLAN 200 and name the VLAN accounting. Next, verify that the VLAN is also configured on switch 2. So let's go to switch 1. Let's do a VLAN 200 name of accounting. All right, let's do an exit. Go to switch 2. Let's do a do show VLAN brief again. And we can see that the VLAN 200, which name is accounting, has been propagated over to switch 2. All right. So on number 7, it says on switch 1 and switch 2, issue the command to manually configure the ports that connect to host as access ports. Configure the port that connects to host 1 to reside on VLAN 100, and configure the port that connects to host 2 to reside on VLAN 200. So let's start on switch 1, and let's do a do show run. You see our interface information, and we can see that, let's keep going. So we can see the connection to the fast Ethernet 011 port is the one to the host. All right. So now that we know that, let's do a interface for the fast Ethernet 011 port. All right. And we want to configure it as an access port. So let's do a switch port mode access, and switch port access. They wanted to access the VLAN of 100 for switch 1. All right. Go to switch 2, and let's do a do show run. See what interface connects out to the end device on this switch, and it is the fast Ethernet 011 port as well. So let's do an interface fast Ethernet 011. Let's do a switch port mode access. Let's do a switch port access VLAN 200. All right. So we just configured them to be access ports, and we also configured them within the correct VLAN. So number 8, it says on switch 1 and switch 2, issue the commands to configure port fast feature on each access port. All right. So now we can do a spanning tree port fast over here on switch 2. Let's do it as well on switch 1. Let's do a spanning tree port fast. All right. So on number 9, it says on switch 1, issue the command to configure rapid PVST plus so that switch 1 is always the root bridge for both VLAN 100 and VLAN 200. All right. So on switch 1, let's do an exit. Let's do a spanning tree for VLAN 100. root primary. This is the same thing for VLAN 200, spanning tree for VLAN 200, root primary. All right. So number 10, it says on switch 1 and switch 2, issue the command to verify trunk port configuration, the VTB configuration, the VLAN configuration, and the rapid PVST plus configuration for VLAN 100 and 200. So we're going to start on switch 1. Let's do an in. And let's do a show interface trunk. We can see that the connection, which is to switch 2, all of these ports are using 802.1q encapsulation. Their trunking mode is on. You can see their status is trunking, and they all have the same native VLANs. All right. So our trunk port configuration is looking good. Let's do a show VTP status. Show VTP status. We can see our domain name is configured in the right domain name. We can see that switch 1 is in server mode. We can see our VTP number of existing VLANs within our VTP domain database. So that looks good. Let's do VLAN configuration. Let's do a show VLAN brief. We can see that we have the correct VLAN configurations. We have both VLANs, 100 and 200, and our Fast Ethernet 011 port is connected out of VLAN 100, which is to our end device, which is host number 1 right here. So that looks good. Everything looks good. All right. And let's do the rapid PVST configuration. Let's do a show spanning tree. Show spanning tree. We can see that for VLAN 100, that switch 1 is the root bridge. And we can also see that for VLAN 200, switch 1 is the root bridge. And they both have the configured priority that we wanted, and they are both running PVST plus. All right. So let's confirm everything on switch 2. Let's do an in. Let's do a show interfaces trunk. Should be identical output. Yes, we can see our Fast Ethernet 01 through 4. All of them are using 802.1q encapsulation. They're trunking. They're using the same native VLAN. So that looks good. Let's do a show VTP status. We can see that it has the same VTP domain name as switch 1. It is operating in client mode, which is what we configured. And we can see that they have the same existing VLAN on switch 1 and also switch 2 because they're in the same VTP domain. All right, let's do a show VLAN brief. We can see the two VLANs we configured, which is VLAN 100 and 200. We can see that the Fast Ethernet 011 port is connected off of VLAN 200, which is the accounting VLAN, and that is host 2 in our network diagram. All right. And lastly, let's do a show spanning tree. You can see that we're using PVST plus, and this is the MAC address and priority information for switch 1, and this is the local bridge ID for switch 2. All right. So number 11, it says on router 1, issue the command to create a sub interface named Fast Ethernet 00.100. Configure the sub interface to send and receive IEEE 802.1q encapsulated traffic on VLAN 100. So let's go to switch number, not switch number 1. Let's go to router number 1. Let's do an enable. Let's do a configure terminal. Let's go into interface, Fast Ethernet 00.100. And let's do an encapsulation .1q for VLAN 100. Hit enter there. All right, and now it says on router 1, issue the command to create a sub interface named Fast Ethernet 00.200. Configure the sub interface to send and receive 802.1q encapsulated traffic on VLAN 200. So let's give an exit. Let's go into interface for Fast Ethernet 00.200. And let's do an encapsulation .1Q for VLAN 200. Hit enter there. All right, so let's go ahead and move on to task number 2. It says configure the advanced layer 2 network. In this task, you will configure CDP and LLDP on switch 1 and switch 2. You will also configure Ether channel and LACP to add speed and failover to the trunk between the switches. So right here it says on switch 1 and switch 2, issue the command to display the status of CDP. Next, issue the command to display CDP neighbor relationships and verify that the switches are connected by using 4 ports. All right, so on switch 1, let's do a show CDP. Show CDP. Yes, let's do a show CDP. So we can see that CDP is being sent every 60 seconds. The hold time is 180 seconds. And we're using CDP version 2. So next, let's do a show. Let's do a show CDP neighbor. We can see the neighbor information. We can see that the fast Ethernet 01 through 04 ports are connected over to switch 2. All right. And if we do the same thing over here on switch 2, we can do a show interface. Show CDP. We can see that they're sending packets every 60 seconds. The hold time is 180 seconds. And we're using CDP version 2 as well on switch 2. We can do a show CDP neighbor. And we can see that these fast Ethernet 01 through 04 connections on switch 2 are connected over to switch 1. All right. So now number 2, it says on switch 1 and switch 2, issue the command to globally enable LLDP. All right. So let's go on switch 1 first. Let's do a configure terminal. Let's do an LLDP run. All right. Do the same thing over here on switch 2. Let's do a configure terminal. Let's do an LLDP run. All right. Now number 3, it said on switch 1 and switch 3, on switch 1 and switch 2, issue the commands to display the status of LLDP. Next, issue the command to display LLDP neighbor relationships and verify that the results match the information you obtained from the CDP neighbor output. So first, let's view the status. Let's do a do show LLDP. Do show LLDP. We can see the status is active. We're sending advertisements every 30 seconds. We have a hold time of 120 seconds. And we can see our reinitialization delay. All right, let's confirm our neighbor relationship. Let's do a do show LLDP neighbor. Just spell neighbor. We can see that we're getting the same output for the 4 interfaces that connect over to switch 2. Let's do the same thing on switch 2 over here. Let's do a do show LLDP. We have the same timers, 30 seconds, 120 seconds, and 2 seconds. And let's do a do show LLDP neighbor. And we can see that we also have these 4 connections on switch 2 that connect over to switch number 1. All right. So number 4, it says on switch 1, issue the commands to configure the range of ports that connect to switch 2 as Ether channel group number 1. Ensure that the resulting Ether channel port is placed into an LACP state that initiates negotiation with remote ports by sending LACP packets. All right. So on switch 1, let's do a interface range for fast Ethernet 01 through 4. Let's do a channel group 1 mode, and we want to do active. All right. So on number 5, it says on switch 2, issue the command to configure the range of ports that connect to switch 1 as Ether channel group number 1. Ensure that the resulting Ether channel port is placed into an LACP state that responds to LACP packets it receives but does not initiate negotiation. So on switch 2, Let's go into interface range for fast Ethernet 01 through 4. And let's do a channel group 1 mode, passive. You want to do passive. All right. So now on number 6, it says on switch 1 and switch 2, issue the command to display the ether channel summary and verify that the ether channel group is correctly configured and functional. Next, issue the command to verify that the ether channel group is functioning as a trunk port. All right. So on switch 1, let's do a do show IP interface brief. We can see that our port channel 1 interface is up. All right, let's do a do show ether channel summary. We can see that our port channel 1 is up and in use. And we can see that all of our interfaces are bundled within the port channel, which is good. All right, and lastly, let's do a do show interface trunk. And we can see that our port channel 1 is in the on mode. It is trunking and it's using 802.1q encapsulation. All right, let's verify everything on switch 2. Let's do a do show IP interface brief. We can see our port channel interface is up. Let's do a do show ether channel summary. We can see that our ports are all up and in use. We're using LACP and all of our ports are bundled. Looks good. And let's do a do show interface trunk. And we can see that our port channel 1 interface is up. It's using 802.1q encapsulation and it is trunking. All right. So number 3, it says configure the layer 3 network. It says in this task, you will configure IPv4 addressing on each network device. In doing so, you will also complete an inter-VLAN routing configuration and verify that inter-VLAN routing works. So on number 1, it says on host 1 and host 2, issue the commands to manually configure the IPv4 addresses and default gateways as indicated in the IP address table. When the configuration is complete, host 1 should reside in VLAN 100 and host 2 should reside in VLAN 200. So let's go to our host devices and let's scroll down to our IP address information for each host. We can see our host information, IP address information is right there highlighted. So let's start on host 1. Let's do an IP config /IP. Here we want to do an IP of 192.168.100.10 for host number 1. A subnet mask of 255.255.255.240. All right, let's give that an enter and let's do an IP config /default gateway of 192.168.100.1. Hit enter there. Let's do an IP config /all to confirm. We can see we have the correct IP address .10 and we have the correct default gateway and we have the correct default subnet mask. So everything looks good. Let's do the same thing on host 2. Let's do an IP config /IP of 192.168.200.10. Subnet mask of 255.255.240. IP config /default gateway of 192.168.200.1. Hit enter. Let's do an IP config /all. All right, and we can confirm the IP address information, the subnet mask, and the default gateway. All right, so that looks good. So number 2, it says on switch to issue the command to configure the VLAN 100 and 200 interfaces with IP addresses as indicated in the IP address table. So on switch 1, let's do a exit. Let's go into interface for VLAN 100. And let's do an IP address for switch 1. We have an IP address of 192.168.100.2. All right. Let me highlight all of it actually. All right. So this is VLAN 100, 192.168.100.2.2, 255.255.255.240. All right. Let's do an exit. Let's go into interface for VLAN 200. Let's do an IP address of 192.168.200.2, 255.255.255.240. Enter. Let's do a do show IP interface brief to confirm that we have these SVIs up, and we do, and they have the correct IP address information. Looks good on switch 1. Do the same thing. Okay, it says switch 2, but I'll go ahead and do the same thing for switch number 2 right here. So let's go to switch 2. All right, and let's give its IP address information. Let's do an exit. Let's go into interface for VLAN 100. Let's do an IP address of 192.168.100.3. Let's do subnet mask of 255.255.255.240. All right, let's give an exit. Let's go into interface for VLAN 200. Let's do an IP address of 192.168.200.3. Let's do a 255.255.255.240. Let's do a do show IP interface brief. All right, and we can see that both of our VLAN interfaces are up, and they both have the correct IP address information. Looks good. So number 4, it says, from host 1 and host 2, attempt to ping every other IP address that is configured in the topology so far. What can you determine from the ping results? All right, so it wants me to ping what IP addresses exactly. So it wants me to ping .100.2, 100.3, 200.2, 200.3. Okay, so this ping every IP address. Got it. All right. So let's go to host number 1. Host number 1. And let's do a ping to let's start out on trying to ping host number 2. Let's do a ping to 192.168.200.10. All right. We're not able to ping host 2 because that is in a different subnet and also VLAN than what we are in. So we're not able to ping that. Okay. All right. Let's do the same thing. Let's try to ping switch 2's VLAN 100 and 200 interfaces. Let's do a ping to 192.168.200.3. We cannot ping that one either because it's in a different subnet than we are in, and also VLAN. Okay, it's in VLAN 200, and host 1 is in VLAN 100. All right, so now let's try to ping 192.168.100.3. And we are able to ping switch 2's VLAN 100 interface, and that is because it's in the same VLAN, all right, as host 1. Let's try to ping switch 1's VLAN 100 and 200 interfaces. Let's do a ping to the 200 interface first, 192.168.200.2. And we are not able to ping this address because it's in a different VLAN and subnet than we are in, as you can see from the request timeouts that we're getting. All right, let's look at .100.2. Can we ping that? And we can because it's in the same VLAN that we are in. And let's try to ping router 1's interfaces. Let's do a ping to 192.168.100.1. And we cannot ping up to the router yet. Cannot get up to that router, our default gateway. All right. And are we able to ping .200.1? And we are not. So let's take a look at Boson's explanations. So it says, based on the output, you can determine that host 1 is capable of pinging all of the IP addresses that have been configured on VLAN 100 so far. However, host 1 cannot ping any of the VLAN 200 IP addresses, even though one of those is configured on switch number 1. This is because by design, devices on one VLAN are not capable of communicating with devices on another VLAN without a router to forward packets between them. Although you have configured sub interfaces on router 1 on router 1 for VLAN 100 and VLAN 200, you are not yet configured the sub interfaces with IP addresses. In addition, the physical interface that connects router 1 to switch 1 has not been enabled. All right. So good information to know. So right here on number 5, it says on router 1, issue the command to configure IPv4 addressing for the IP address Fast Ethernet 00.100 sub interface as indicated in the IP address table. In addition, configure IPv4 addressing on the Fast Ethernet 00.200 sub interface as indicated in the IP address table. All right. So we can see IP address table information right here for router number 1. So let's go over to router number 1 and let's do an exit. Let's go into interface for Fast Ethernet 00.100 first. Let's do an IP address. 192.168.100.1. Let's do a subnet mask of 255.255.255.240. All right. And let's give an exit. And let's do an interface for Fast Ethernet 00.200. Let's do an IP address of 192.168.200.1. Let's give a subnet mask of 255.255.255.240. Hit enter there. Let's do a do show IP interface brief. And we can see that we have the sub interface IP address information configured, and that our Fast Ethernet 00 interface is administratively shut down. So we're going to have to enable that interface to get these sub interfaces up as well. So it says on router 1, issue the command to enable the Fast Ethernet 00 interface. Let's go ahead and do that now. Let's do an exit. Go to interface for Fast Ethernet 00. Let's give a no shut. Now if we do a do show IP interface brief, those sub interfaces should be up, and they are. All right. So now it says from host 1 and host 2, verify that inter-VLAN routing works by pinging every other IP address in the topology. All right. So now let's go ahead and try this. Let's try .200.1 now, which is in a different VLAN and subnet, and we can ping router 1's Fast Ethernet 00.200 sub interface. Let's do switch 1's VLAN 200 interface, which is in a different VLAN and subnet as host number 1. Let's do a ping to 192.168.200.2. We can ping switch 1's VLAN 200 SVI interface. Let's do the same thing for switch 2. Switch 2's VLAN 200 interface is on a different VLAN and subnet than host 1. But let's ping that address since we just enabled inter-VLAN routing. Let's do a ping to 192.168.200.3. We are able to ping switch 2's VLAN 200 interface. And let's ping host number 1. Let's do a ping to 192.168.200.1. And we are able to ping host number 2 as well. So lastly, on number 8, it says on each networking device and a topology, save the running configuration so that devices are configured correctly when reloaded or power cycled. All right. So let's go on router 1. Let's do an end. and we can do a copy running config to startup config. Yes, let's go ahead and save that. Do the same thing on switch 1. Let's do an N. Let's do a copy running config to startup config. Save that. And lastly, on switch 2, let's do a N. Let's do a copy running config to startup config. All right. So that looks to be the end of the lab. Let's hit grade, and hopefully we did everything correctly. And we didn't. So let's take a look at what we did wrong in this lab. Okay, so it wanted me to configure the actual channel group protocol to be LACP. So I can get that changed. And is that the same thing that it wanted on switch 2 as well? Because if so, I can get that corrected. Yeah. So that's an easy correction. It wanted me to do, actually specify the actual channel group to be LACP. All right. So let's do a configure terminal. Let's go into interface for fast Ethernet 01 through 4, because that's where our ether channel was. Interface range, interface range, fast Ethernet 01 through 4. Let's do a do show CDP neighbor just to confirm that. Yeah, so fast Ethernet 01 through 4. All right, let's do a channel protocol of LACP. That's what it wants. Okay, range terminated because it failed on the 01. So I'm gonna have to delete the whole channel group first. So let's do a channel group. Let's do a no channel group 1 mode active was the one over here. Now let's do a channel group channel protocol. So a channel protocol LACP. Now let's do a channel group. See, it worked that time. Channel group 1 mode active. All right. Now I have to do the same thing on switch 2. Let's do a configure terminal. Let's go into interface range for fast Ethernet 01 through 4. Let's do a no channel group 1 mode passive. Let's do a channel protocol of LACP. And let's re-enable that again. Channel group 1 mode passive. All right. That should work now. And let's do an N. Let's do a copy running config to startup config. Yes. And let's do the same thing over here at N. Copy running config to startup config. All right. Let's hit grade now. And now everything is correct. So I appreciate you guys for watching this one, and I'll see you in the next one.